Okay, we want to talk more about systems of equations and how to solve them using matrices. First, we're going to use a method that you've already seen before. Okay, we're going to take a regular system of equations. All right, we got negative 2x plus y equals 42, and x minus 3y equals 75. Okay, we're going to solve this actually using substitution first. So what I'm going to do is, this one looks easier to deal with. Okay, so I'm going to take this and solve for x. So I'm going to move negative 3y over here, but I have to add it to both sides to do that. So we get x equals 75 plus 3y. Okay? Now, since I know what the value of x is, I'm going to plug it into the other function. Okay? So I'm going to have negative 2 times the value of x, which is 75 plus 3y. Then I'm going to add y, because it was a part of my original function, equals 42. Okay? Now I have to distribute my negative 2, combine any like terms, and then solve for y. So this becomes negative 150 minus 6y plus y equals 42. Okay? Combine these, I get negative 150 minus 5y is 42. Okay? Now I'm going to move the 150 over here, so I have to add it to both sides. I get negative 5y equals 150 plus 42 is 192. Okay? That gives me y is 192 divided by negative 5. Okay? Not the prettiest of solutions, but that's okay. That's what it is, and that's what it is. Alright, now I'm going to plug it back into either one of those functions, and I should find out what x is. Okay? How about we go with the top function? So negative 2x plus, which in this case is actually a negative 192 over 5 equals 42. Alright, now this might get ugly, but don't worry, fractions are your friends. Don't freak out. Okay, I'm going to add this to both sides to isolate minus 2x. Okay, but to do that, I have to have a common denominator here. So, what I have to do is convert 42 into a fraction. Okay, so 42 times 5 will give me 210 over 5. Alright, now I can add. I'm going to get negative 2x equals, if I add 192 and 210, that should give me 402 over 5. Okay, now all I have to do is solve for x. So x, if I divide both sides by negative 2, or in this case I'm multiplying by 1 over negative 2, which means I can actually reduce some things here. This becomes 201, and that goes away, leaving only the negative, leaving the 201 over 5, and it is now negative. Okay? So, my solution set should be an x value of negative 201 over 5, and a y value of negative 192 over 5. Okay? So if we want to check that, all we have to do is plug them back in and see if that's what we get. Okay, so in the first equation, 2 times x, which is, or I'm sorry, negative 2 times x, which means it would become a positive value, would be 402 over 5, and then add y. And that is actually going to give me 210 over 5, which is in fact 42, the answer of my original function. Okay? Alright, so we know these work. Alright, I'm going to store these somewhere where I don't erase them, and we can work with our matrices. Okay, how about if I try and put them down here in the corner? There we we go. Perfect. We're going to tuck those away for now. And we're now going to solve the system using matrices. Alright, it's pretty simple. Alright, first thing we need to do is find our coefficient matrix. Alright, we're going to call it C. Oops, we can't see that, sorry. So C is going to be a 2 by 2 matrix. And all we're going to do is take the coefficients from our functions here and plug them into our matrices. So we've got -2. This is 1, 1 here, and -3. Okay? Now our variable matrix is just x and y. So if you want to see V, it's just going to be a column matrix with x and y as the elements. And then our answer matrix is also a 2 by 1. It's made up of the answers to our original equations. So it's going to be 42 here and 75 there. Okay? Alright, now that we've got these, we have to find something in particular. We have to use our coefficient matrix and we have to find the inverse of it. And remember, the inverse, okay, is denoted by the -1 exponent. And here's our function, or our formula. It's going to be AD minus BC as our denominator. Now AD minus BC, if you remember, is our determinant. Right? And then we're going to change our original matrix around. Okay, A and D switch places, so we have 3 here and -2 here. I'm sorry, -3. And then we are going to negate the other 2 terms, but they're going to stay put. So we got -1 and -1. Okay? And we need to go ahead and plug these in. So A is -2 times D, which is -3, minus 1 times 1, which is 1. Okay? So this reduces to 1 over 6 minus 1, which is 5. Okay? So 5 is our determinant. We bring down our inverse. Okay? That is the value of our inverse. Okay? Now what we do with our inverse is we're going to multiply it by our answer matrix right here. Okay, so we're going to leave this as it is. And we're going to multiply by 42 and 75. Alright? Now when we multiply a 2 by 2 matrix by a 2 by 1 matrix, we're going to get another 2 by 1 matrix. So we're going to have, remember, I'm not using my scalar yet. I'm not multiplying it in yet because that's going to get messy. So I'm going to leave it out for now. What I'm going to do is I'm going to go ahead and set up my answer. Okay? Now we do -3 times 42, which should be, let me go ahead and create a little piece of scratch paper here. So -3 times 42 is going to be -126. And then -1 times 75 is -75. Now if we add those two together, what we get is -201. And that's the first part of our solution. Okay, the second piece, -1 times 42 is -42, and -2 times 75 is -150. When we add those together, oops, I cannot see that. Let me slide that over. There we are. So -42 and -150 give us a total of -192. Okay, so this goes here. Now it's starting to look familiar, isn't it? Okay, now all we have to do is carry out our scalar multiplication. When we do that, we get -201 divided by 5 and -192 also divided by 5. Now if you notice, that is the same answer we got before. Okay, so you see, you can solve systems of equations using both elimination and substitution. Of course, we didn't cover elimination in this video. And you can also use matrix operations. Okay, we just have to find the inverse, multiply it by our answer matrix, and voila, we get our solution. Okay, it's not the prettiest of solutions, but sufficient enough to show you that it works. Okay, let me know if you have questions, guys.